Welcome to Guide Guru. We hope this video helps.
You begin by writing the matrix clearly and choosing whether to work with rows or columns. I recommend rows for most cases. Scale and swap rows immediately to create a leading non-zero in the top left. Once done, eliminate entries below that pivot by adding suitable multiples of the pivot row to lower rows. Make sure to record each operation so you can reverse if needed. These actions expose the first pivot positions that determine the rank. Now move column by column. For each new pivot, find a non-zero entry, swap it into position, and eliminate everything below. Once you have zeros beneath each pivot, scale pivot rows to make pivots convenient like one to ease comparisons. Keep reducing until no further complete pivots can be formed. This produces a row echelon form. Because pivots are independent rows, counting them gives the rank. But first ensure no hidden dependencies remain among remaining non-pivot rows. To finish, count the non-zero pivot rows in your echelon form. That count is the matrix rank. Once counted, verify by expressing any remaining rows as linear combinations of the pivot rows to ensure none add a new independent direction. If results seem off, reevaluate arithmetic mistakes. A small calculation error can hide a pivot. As a troubleshooting tip, try performing column operations instead or compute the rank of the transpose. Both must match and often reveal missed pivots.
Thanks for watching. Consider subscribing if we helped you today.